Now we'll see how we can go for a 8-point DFT. Okay. So the same example we are going to have 8-point DFT. We are given x of n already we are knowing is 1 by 3, 1 by 3, 1 by 3. But we want to find 8 point. So take this to periodicity of 8. So we have the length is equal to 3. L is equal to 3. So n minus L, that is 8 minus 3 is equal to 5 zeros. I have to I have to append. Append means attach. So my xn will be 1 by, this is called as a periodic xn, 1 by, sorry, 1 by 3, 1 by 3, 1 by 3, and 5 zeros. Okay, and 5 zeros. Now I have the original formula for me, which I remember. I shall write it once again. N is equal to 0 to n minus 1 x of n e raised to minus j 2 pi nk by n. Okay. This is all that we are going to have. Now to start with, now n is equal to, we'll make a simplified equation so that whenever we go for the new value of x of k, we'll simply have to insert the value of k and no more modification. So that will be easier to handle. So just see, when n is equal to 8, okay, when n is equal to 8, I will make the changes like this. X of k is equal to summation n is equal to 0 to 8 minus 1 x of n e raised to minus j 2 pi nk by 8. Okay. So this will give me n is equal to 0 to 7 x of n e raised to minus j pi nk by 4. Okay. Now what is left for me is to expand this. Okay. Now I have everything simplified here. So there is no harm in inserting the value of n. Now x of 0, e raised to 0 obviously. Now inserting all values of n. I am putting the first value now, x of 1, e raised to minus j pi, n being 1 here, so it will be e raised to minus j pi k by 4. Pi k by 4. Plus x of 2, second value, e raised to minus j 2 pi, no n, n has been inserted as 2. Next, x of 3, e raised to minus j 3 pi k by 4. Now this we don't have to simplify, we have done it once. Now x of 4, e raised to minus j 4 pi k by 4. And we have x of 5 e raised to minus j 5 pi k by 4. Then the sixth value is e raised to minus j 6 pi k by 4. Okay. Then the seventh value, the last value, e raised to minus j 7 by k by 4. And that's all. Now we'll observe here, we have values from only three samples are there. This is 1, this is 1, this is 1. So there is no sample for x of 3, is it not? We don't have here, we don't have a sample here, these are all zeros, zeros and zeros. They're all zeros. So what we will do is, we will simply go for simplifying this once again. This is going to be e raised to 0 is 1 plus x of 1 is 1 by 3. We will keep this as e raised to minus j pi k by 4. Hmm? Then x of 2 is 1 by 3 e raised to minus j pi k by 2, because 2 by this 4 will divide, division will be simplifying with this. So I have other values all 0. Okay, so x of k, I am getting 1 by 3 1 by 3 1 plus, now I'll put this formula e raised to j theta is equal to cos theta minus j sin theta. If it is plus, it is plus e raised to minus j theta cos theta minus j sin theta. As we are usually doing this. So here I will be using common 1 by 3 is taken. So I have left with only cos pi by 4, sorry, pi k by 4 minus j sin pi k by 4 plus cos pi k by 2 minus j sin pi k by 2. This is what in hand I am having. Now to find, this is my equation which I will be carry forwarding this for all the values of k. Okay, I will just have k equal to 0. I will find the first value x of 0. This will be nothing as 1 by 3. Insert the value of k as 0 everywhere. This will be 1 plus cos of 0 is 1, cos 0 minus j sin 0 is 0, cos of this k0 is 0, this minus j 0. So this is going to be 1 by 3, 1 plus 1 cos of 0, is it not? 1. This also is going to be 1. So this is going to be C, 2 by 3. That is the answer. Okay. So what is 2 by 3? Everybody knows now. 2 divided by 3. Is it 2? So am I wrong here? Yes, we are right. Because 3 by 3 is going to be 1. Very good. So this was a 1 value. It's not 2, it's 3 by 3. Now when k is equal to 1, when k is equal to 1, when k is equal to 1, k is equal to 1, I will put the insert the value. I will first again write this because it is on the last page. X of k is 1 by 3, 1 plus cos pi k by 4 minus j sin pi k by 4 plus cos pi k by 2 minus j sin pi k by 2. Okay. Okay, now you have to insert the value as k equal to 1. So this becomes 1 by 3, 1 plus cos pi by 4 minus j sine pi by 4 plus cos pi by 2 minus j sine pi by 2. Cos pi by 2 is 0. So what you have is 1 by 3, then 1 plus cos pi by 4 is 0.707. You can calculate on the calculator. Minus j 0.707. Sin 45 and cos 45 are same. Plus this is 0. Minus j sin pi by 2 is always 1. So it's going to be 1. So we will simplify this, take the real term together. 1.707 minus 1.707g. Okay, so I'm having x1. I will make it here as 1.33. It becomes division. You can have 1.7. You can take in common. 1.707 divided by 3, 0.569. 1.707 divided by 3, 1 minus j is giving you x of 1 is equal to 0.569 minus 0.569 j. We have to convert this to polar. So we know that polar form. Let us check whether it is in the complex form. It's already in the complex form. So probably you remember how to go for the complex. 0.569. Is it not? Right, minus 0.569. I want the polar, this imaginary part. I want to use this function. I have an equal sign. It's giving me 0.804, and the angle again is shift minus 45 degrees. If you want to convert this to 0.04, simply divide by 180 degrees into pi. Okay, 45 divided by 180 minus 0.25. So 0.804 minus 0.255 radians. You can use this also for plotting. Okay, radians. Keep this aside. Now I'm having x of 1 as this one. Similarly, now for k is equal to 2, we'll have this 1 by 3, 1 plus cos pi by 4 into 2 minus j sine pi by 4 into 2 plus cos pi by 2 into 2 minus j sine pi by 2 into 2. Okay. What is happening is, by practice you will be able to do it fast. So this is 2, this is, rewrite this 1 plus cos pi by 2 minus j sine pi by 2 plus cos pi minus j sine pi. Now you see this is 0. Let us make it simplified. 1 plus cos pi by 2 is 0 minus j. Then this is minus 1 to minus 0. Okay. So you have this getting cancelled. You have minus j by 3. It is minus 0.33 angle minus 90 degrees. Okay. So this is minus 0.3 angle. This is absolute. It's minus pi by 2 radians. Then you have k is equal to 3. X of k is equal to 1 by 3, 1 plus cos. I have made the solution here. Cos of pi 3 pi by 4 minus j sine 3 pi by 4 plus cos 3 pi by 2 minus j sine 3 pi by 2. So we can go forward with saying 1 plus cos 3 pi by 4 minus j sine 3 pi by 4 plus cos 3 pi by 2 minus j sine. We can say it's going to be, I've rewritten this actually, 1 by 3, 1 minus 0.707 minus j 0.707, then plus 0 minus j into minus, it's it is 3 pi by 2 minus. So you have 1 by 3, 1 minus 0.7, 0.293, this plus j minus this, it is 0.293 j. So you have 0.097 plus 0.097 j. This is coming as 0.1345 degrees or 0.13, 0.25. Similarly, you have the x4 value coming as this. Similarly, you have x5 value. Then you have x6 value. This is x6. x7 value. Okay. You can get it as x6. And x7. So we are having x6 and x7. I will just have a copy here. Point 0.569 plus 0.569 g. Now to plot this, again you have to go for x of k magnitude spectrum. It's going to be like this. K values. This one we have 8 order, is it not? So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So to plot, you have x0 value. You'll have to find the magnitudes here. It is 0.845 degrees here. Okay. Let us see now at this point, 0.2, 0.4, 0.6, 0.8 and 1. So when I'm having x0, that means I'm getting the value as x0. Then the first point is 0.8. I'm having the magnitude, is it not? I will collect only the magnitude part like this. It will be plus x2 is 0.33, x3 is 0.13. Then I have x4 is 0.33. Then you have x5 is 0.13, x6 is 0.33. 0.33 will be more than this, okay? 0.33. Then x7 is 0.88. And if you go for this 8, you'll see it will be, the next cycle will be repeating. So you have n is equal to 8 here. And if you go for the phasor spectrum, similarly you can draw it 5 by 4, 5 by 2, minus 5 by 4, 5 by 2. So you are having 1, 2, 3, 4, 5, 6, 7. So we are having x0 is 0, x of 1 is 45 degrees minus, that is, this is 45 degrees. X of 2 is minus 5 by 2 like this. 3 is 45 plus, 4 is 0, 5 is minus 45, then 6 is 5 by 2, then 7 is 45. So we are getting values like this. So the same way that we had obtained for the PDFT. We can just check out the nature is same. Okay. You just see if n is increasing, this mod of x of k will be approximately x of omega. That was about the 8-point DFT. Okay, let us. So this is all about 8-point DFT.